Hi, welcome to this part where we are looking at Amazon SQS 30 plus thumb rules. Please remember the concepts explained here is very important from a certification standpoint. With certifications, primarily these three. Please subscribe to my channel for more such informative content. Now, in today's topic, we will cover these. This is our agenda. First is we will go through the SQS purpose, how it is different from these tools like Kinesis, etc., which are used in the middleware kind of technologies, how the billing works, and the different other features of SQS. Let's jump into this. The first question is, what is SQS? It is a simple queue service. It requires no administrative effort and it works on a massive scale. So whenever we talk about any service in AWS in the cloud world, it's all about scalability. And, there are 3 points: scalability, reliability, and availability. But scalability is one of the massive points, and if you can massively scale up, that is required. Now, what is scale up actually mean? Take this example of a restaurant. In a restaurant, if 10 people come, you should be able to entertain. But if 100 people come, you should be able to entertain. Obviously, in restaurants, there is a upper mark. Like you say, you cannot scale beyond 500 people because that is the all the seating arrangement you have. But SQS is a virtual world. It is unlimited. So if you see any web application, it has 3 tiers: front end, back end, and database. And nowadays, most of them use microservice based architecture. This is a simple architecture, and what happens there is any communication from front end to back end to database. So example, if you are entering an order, you go to amazon.com and you are entering an order. Okay, so what is your front end here? So I've just shown flipkart.com, and this is the front end of flipkart.com. And the moment you buy something and put an order, it goes to the backend. And how it goes here, some messaging service is used, because if it sends directly and waits for it, the end users might experience slowness. So even when you push the order, you get a confirmation, but it may not be necessary that the entry has been made in the database. It might still be in the queue. That queue service can be SQS, in queue, and so on. So this is the real world applicability of SQS. Now there is a product called SNS. If you want to send certain set of messages, SMS, email, or mobile push notifications, if a certain event happens, then we use SNS. So this service is very different to SQS, where SQS main purpose is that in this diagram it communicates between the front end and the back end and the database and so on. But SNS, on the other hand, is purely a messaging service considered as an email, SMS, etc. Now, if you are an amateur and starting with AWS for the first time, then you should build your services using SQS. But suppose you already have an existing application and you are already using some sort of messaging service like message queue, etc., then it is recommended that you use Amazon MQ. That's the difference. If you are already using some messaging service, then you should use Amazon MQ on the cloud world. But if you are starting fresh, you are building your application from scratch, you should use SQS. Now, when the front end sends the messages, so front end becomes the producer and the backend is the consumer. So in terms of middleware services, this term is very important: producer and consumers. Producer produces messages, consumer consumes these messages. So for example, in this case, producer front end, it will send the orders that you have booked, and the backend will then analyze this and see if these are in the inventory or not, and so on. It does some sort of business logic check. So he is the consumer. So when the messages are sent, it is sent using this logic: FIFO, first in first out queues, so that it preserves the exact order. You can use standard, but standard will not preserve the orders. FIFO will preserve the order in which the messages were received. So in certain times, FIFO is better because there is a sequence in which the orders are being sent across. So the messages, it will flow in the same order. Now, so we understood that there are 2 sort of queues: standard queues and FIFO queues. Standard queues, the order, the sequence of the order is not guaranteed. FIFO queues, the sequence of the order is guaranteed. If you send 3 messages, it will go in the same sequence. But in standard, if you send 3 messages, it may not be necessary that it will go in the same sequence. It might happen the first message went first, the third went next, and then the second message went. But in terms of FIFO, message 1, 2, and 3 will go in the same sequence as 1, 2, and 3, not as 1, 3, and 2. But there is a beauty. Standard queues, they provide you at least once delivery. That means nothing will be lost in between, and it makes it more better. FIFO will also have the same thing, but here the message will be delivered at least once. Now, what is the difference between Kinesis and microservice? Kinesis we should use only for real-time streaming. For example, you want to collect process, like you have IoT devices, scanners, sensors, and you want to constantly see what your sensor is sending it, then you can use Kinesis. But SQS, like I told, if you have a microservice based application, it is the best fit to use SQS here. Or if you are already using some other middleware, then convert it to Amazon MQ. But SQS is the best choice if you're starting afresh. Now, in this world, nothing is free. Everything is about money, cost, price, etc. So Amazon provides you a free tier which will give you 1 million requests per month at no charge. Beyond this, it is chargeable. Okay, remember this for the certification exam. This comes in the certification exam whether I need to go with a pricing model or not, and I am quite under 1 million, and that is the key for you. If it is under 1 million, free tier would work. And whenever we talk about billing, it is all about how do I know what I am being charged at. You have a credit card bill, you can immediately see your bills every day. You don't have to wait for a month to see the transactions hitting your credit cards. Similar to that, you can tag and track your queues for resource and cost management using allocation tags. So tags, we already know, we use tags to allocate certain resources, to tag it to the resources, so that when in the bill, when you see that the tag is related to, for example, SQS, you know that okay, these are my SQS charges, these are my MQ charges, these are my compute charges, these are my storage charges. So you should create such tags so that it is very clear where you are spending the maximum amount of money, where you want to control your spendings. Now, suppose you have SQS provision, can it interact with other services like EC2? The answer is yes. Can it interact with storage services like S3? This S3. The answer is yes, it can interact. And that is our next thumb rule, that you can integrate, use SQS with these services, EC2, ECS, Lambda, as well as with storage services like S3 and DynamoDB. DynamoDB is a database. The storage service is S3 and database service is DynamoDB. You can use with all of these. So in this diagram, if you see, SQS is on the left hand side, it can interact with all of these services on the right hand side. Okay, so for example, you are getting messages from SQS and you want to keep it in S3, you want to analyze it, you can do that. You want to enter it into DynamoDB to store it and do some further investigation, you can do it. You can put it in EC2 instances as a storage, or like for compute, you can, SQS can interact with EC2. You might have some application on EC2 instance which will run through these messages from SQS and make sense out of it, or you can do a serverless compute using Lambda and process these messages. Okay, now consider a scenario. This producer is sending messages to consumer. It keeps sending, and some messages are just the retry is happening. This consumer is not consuming it due to some reason, maybe technical issue or some reason. Now, what to do with these messages which are not getting processed? Okay, what to do with that? You can keep them in dead letter queue. You can create a dead letter queue. It receives messages after maximum number of processing attempts. Suppose you say 10 times. This producer should send one message to consumer 10 times. Like it will not send it 10 times all the messages, but the message, suppose once the message is sent, consumer doesn't consume, again send it 1, 2, 3, again send it 4. If it is not consuming, again send it. So you can set after 10 times, if the consumer is not consuming it, you put it in the dead letter queue. So after maximum number of trials, what you are doing is, instead of going to consumer, it goes to dead letter queue. This gray box is the dead letter queue. Okay, and this question definitely comes in the exam. Some of the other exam it will definitely come. So what it says is, in dead letter queues, you can isolate messages that can't be processed for later analysis. So you are storing it and then you can investigate in the real time. What happens is, like I gave the example of Flipkart. Okay, so that is a Flipkart front end. It sends a message to back end. The order is created, the user is satisfied, I bought my stuff, the order is created, but somehow the order is still in the SQS queue. It is still not hit the backend, and now consumer says I'm not able to consume it due to some problem. Okay, then you cannot say okay, I'll delete this. Then the order, who will fulfill the order? The end user, you have taken the payment, who will fulfill the order? So in order to do that, you have to save it in the dead letter queue. Once it goes to the dead letter queue, you will ask your IT team to see if you can manually process this, because the customer, the end goal is the customer should get whatever they have ordered. Okay, that is the end goal. Hence we say we will store these isolated messages for later analysis. That is the important thing. Now there is a beautiful concept called visibility timeout. This is the period of time SQS prevents other consuming components from receiving and processing a message. So in this case, you have this front end, okay, and the front end is a producer and it sends the messages to consumer. Now what if the consumer has consumed it? Okay, you send one message from here to here and the consumer has consumed it. Now after consuming, the consumer will have to fire a delete for this message. If it doesn't fire, producer will not automatically know that the consumption has happened and the message will be left there. That is the visibility timeout. So you have to decide after how many seconds, how many minutes after consuming you want to delete that message. So that is visibility timeout. Now the metadata of the message is very important. Why it is important? Because you can structure, you can use, there are 10 metadata attributes. You can structure the message, you can keep a separate body so that when the consumer, when this consumer is trying to consume, it will straight away go to the body and consume. It doesn't have to go to other stuff, so that way the performance would be slightly better. So in SQS, if you want to increase performance, then you should use this method. So this is also very important from the exam perspective. If they ask you a scenario and you want to improve the performance, you can use some of these attributes or metadata attributes to improve it. Another important thing from exam standpoint is this time in queue value. So they will give you a scenario, especially in the solution architect associate exam, they will give you a scenario and then you will have to say whether this amount of time in value is good enough or not. So this is calculated by subtracting the sent timestamp value with your current time, that is equal to the time in queue value. Now suppose producer is sending the message to the consumer, okay, how much time it takes in between to consume it, totally sending and consuming? It takes as low as milliseconds, some low as like tens to hundreds of milliseconds. It takes that much low. So if you are sending a message, if you are receiving a message, if you are deleting a message through API requests or whatever, you get this kind of latency. And this is also important, it gives you tens to low hundreds of milliseconds latency. Now a very important topic from exam standpoint is long polling. This is definitely it is asked in the exam, very important topic. So what is long polling, what is short polling? That is important. Suppose this producer sends a message to consumer, okay, now consumer is trying to poll and see, do I have a message, do I have a message in the queue? So this consumer will constantly keep polling in that message queue and see, do I have a message? Suppose there is no message, so if you are doing a short polling, you will immediately come to know that the message queue is empty, there is no message there. But if you are doing long polling, it will not tell you immediately that there is no message. But long polling is a bit different. The consumer will keep polling and going to the queue and say, do I have a message, do I have a message? So it will not immediately say, no, I don't have a message, I don't have a message. It will not immediately say that. What it will do is, it will keep polling. Once it gets a message, then it says, hey, I have a message. So there are different scenarios where you can use long polling. Usually the recommended practice is, in the exam, if you get questions, always prefer long polling over short polling. Now what should be the long poll timeout? Maximum 20 seconds works, you should keep it less, but maximum 20 seconds, because higher poll times reduces the number of empty receive message response instances. Okay, so that's why we are saying keep it maximum 20 seconds. See, if you know that this producer can send messages even after a minute, then you can keep the long poll setting as uh, 60 seconds or 40 seconds. But if you know that maximum 10 seconds delay will be there, so you can keep a long poll setting of 10 seconds, up to you. Like I explained before, SQS works very well with SNS. Suppose there are scenarios where some event happens, you receive a notification and then you have to process the messages in SQS queue. That is also possible. Now see, between producer and consumer there is a queue. You have to delete your messages. See, consumer has consumed a lot of messages, you want to delete it. Deleting one message at a time is not very ideal. So what you do is, after certain time, when the processing is done, fire a purge queue action. Okay, that will ensure that the queues are totally vacant now. This will also come in the exam. I have seen these questions multiple times. Now the advantage of FIFO is you can never introduce duplicate messages. Now this also comes in the exam. They give you a scenario and then say I'm already using FIFO, and then they will give you options and you have to choose the right answer. But always remember, when you are answering such questions, if you are quizzed around duplicate messages, FIFO duplicate messages is impossible. So now you can say, hey, what if this producer sends the same message? I know FIFO, the queue will have some mechanism to understand duplication, but what if the producer sends duplicates? The producer is wrong. Then you will end up sending the duplicate message to consumer. No, there is a deduplication functionality built in SQS FIFO which will prevent that from happening. So hence we are saying duplication is not possible. Now a lot of time people say I already have SQS and they are using standard SQS. Can I convert that to a FIFO SQS, because FIFO SQS is better than standard SQS? Just one example, there is no possibility of duplication of the messages. It's a good check that you can put through FIFO SQS. Now that conversion directly is not possible. However, you can have a feature which moves. Okay, there is a feature which will help you do that move. In the exam I also saw some questions typically in cloud practitioner and associate solution architect associate, where they talked about I have a service like scaling live hooks and I'm using FIFO queues and those kind of stuff, and the clear answer is FIFO queues cannot work with lifecycle hooks, IoT rules, and lambda dead letter queues. It cannot work. See, whenever you have any sort of infrastructure, we always want to monitor this infrastructure. Any EC2 instance or databases and so on, we will have to monitor. Even in the on-premise world, we have monitoring tools to monitor the applications, infrastructures, VMs, and so on. So what do we monitor? We have CloudWatch metrics. See, the de facto tool for AWS, if you want to set monitoring, is CloudWatch. Now what metrics you can monitor? These three metrics you can monitor: approximate number of messages delayed, approximate number of messages visible, approximate number of messages not visible. Now in the exam I would suggest you make yourself very much acquainted with these three. In solution architect associate exam you will definitely get questions around this, where they will give you a scenario and then the options might have one of these. If you don't understand the difference, then it will be difficult to answer it. So this also you should understand. Now take the example of first one. Okay, now all of you must have made a booking through IRCTC and you are traveling by train. If you see in India, majority of the trains, at least to some extent, some of them are always delayed. Okay, now it's the same concept here. It's a delayed queue. So won't you want to know, like the people who are railways staff, won't they want to know that which trains are delayed? It's similar to that. Won't you want to know that which messages are delayed? That is something you want to know. The another thing is the second one, approximate number of messages visible. What it means is the messages are available. That means in this queue the messages are available, but the consumers has not consumed it. It is visible. That is also an indication for you what is happening. Something is wrong with the consumer. Why the messages are visible and consumer has not consumed it? See, now another example, third one is I told you that the messages will continue to remain in this queue even after consumers have consumed it, because the consumer's responsibility is to consume and then delete the message. Now you would want to know there are how many such messages that are lying here which has not been deleted, so that you can fire a purge delete. That is all what point number 3 is stating. See, one thing to note about FIFO queues, and this is also important for certification, because the certification would quiz you that I have many producers. I'm using a FIFO queue, and as a part of the FIFO queue, I already know this queue is there, but I have many producers and one consumer. Can the FIFO queue work? Yes, FIFO queue can work even if I have multiple producers and one consumer. But the FIFO queue will not work vice versa if you have one producer and multiple consumers. So this is our next thumb rule. Now this thumb rule, it is not important for the certification. It is a good to know that it supports 3000 messages per second. Now in the cloud world, people are worried about high availability. What does that mean? So this guy producer is sending messages to consumer, and there are so many messages kept in the queue, and the consumer is consuming it one at a time. What happens if this AZ goes down? Will I lose my messages? Imagine you made an order on Flipkart and you get a message that it has been successfully booked, but somehow that message in transfer got deleted, or because of the system failure. So that is our next thumb rule, which talks about availability. So just like other services of AWS, this is also highly available AWS region, and it maintains multiple redundancies across AZs. So if one AZ goes down, the other AZ will be still there. You know always that there are always at least 3 AZs, and if one goes down, the other will be there to support it. Even if there is a computer network failure or AZ failure, it can still manage it. So it is a highly available service. And then comes the question of security. So this is a good to know that SQS transactions, all messages are secured, and it uses TLS protocols, and there is also a provision of server-side encryption with SQS. Your messages can also be encrypted end to end. One thing to note is this is very important from an AWS Cloud Practitioner exam. If you have deleted a message, you cannot retrieve it again. You cannot. I'm sorry for this, but this service is built so that you should not end up with duplicate message processing. And as a part of that, if you or this consumer has deleted the messages, there's no way to bring it back. Why? Because it has been processed and then deleted, so there is no way to bring it back. Now this is the message retention frequency, 1 minute to 14 days. You can retain it. Default is 4 days. Okay, and you can use this function. So you can get a question around message retention period. What can be the potential values? It can be between 1 to 14 days. This question comes in the AWS Solution Architect Associate and Professional exam. And the messages, they support XML, JSON, and other unformatted text formats. Now this is just as an information. This question or this topic is not important for certification, but I have put it so that you know that there is a quota of 120k for the number of in-flight messages for standard queue and 20k for FIFO queues. And this is also important from the exam perspective. They will give you a scenario and then they will tell you that I have a different AWS region, and can I use that message queue in another region? I cannot. It can only be used in the same region. This is a question which can come in AWS Solution Architect Associate or Professional. See, in a single region, there are no changes for data transfer between SQS and these services. The SQS works with these services. There are no data transfer charges within a region. Okay, so that's the beauty. You can save costs. And this rule talks about dead letter queues. What is dead letter queue and how the processing happens? You can understand this from a processing standpoint because this is relevant in the exam. And in the last rule, you should always remember a better design is that which makes use of FIFO dead letter queue with FIFO queues. You cannot use a standard dead letter queue with FIFO queues. You will have to use a FIFO dead letter queue with FIFO queues. Always remember this. There is something called FIFO dead letter queues and dead letter queues. You should use FIFO dead letter queues with FIFO queues, and you will get a similar question in the exam also related to this topic. This is the last thumb rule for this part. Please subscribe to my channel to get more such informative contents. This brings us to the end of this part. See you in the next part.